Hi everyone! In this video we are going to understand the fundamental structure of an internal combustion engine cylinder. We will identify the main components, explain their function, and then later connect this physical structure to engine modeling in GT Power. As you can see in this picture, we have cylinder head. The cylinder head is the upper part of the engine. It seals the combustion chamber and contains intake valve, as you can see, an exhaust valve, a spark plug. So, it is exposed to high temperature and pressure during combustion. You can see the picture. Left side we have intake valve. So the intake valve allows the air or air-fuel mixture to enter the combustion chamber. Opens during the intake stroke, controlled by the camshaft. Its timing strongly affects volumetric efficiency. And the exhaust valve, the right side, allows burned gases to exit the cylinder, opens during the exhaust stroke, operates at very high temperature, and critical for engine bracing and thermal loading. And about the spark plug, ignites the compressed air fuel mixture. Okay. In this picture we have combustion chamber. Is the volume above the piston when it is near TDC, where fuel combustion occurs. And shape affects turbulence and flame propagation, directly linked to compression ratio. Okay. We have cylinder wall, piston ring that involve seal combustion gases, control oil consumption, and transfer heat from piston to liner. And we have piston pin, connects piston to connecting rod. Connecting rod converts reciprocating motion into rotational motion. Crankshaft converts linear motion into rotational motion. Okay. On the right hand side you can see engine cylinder that you can design in GT Power. Let's go to next slide. Here we have 4 cylinders engine that we can design in the GT Power, and we can go through that now. Okay, now that we understand the physical components of the engine cylinder, in the next part of this video we will translate this real geometry into a one-dimensional simulation model using GT Power, and we will define bore, stroke, valve timing, combustion parameter, and analyze engine performance. Let's go to new page. Okay, to design cylinder. And here we can find engine cylinder icon, drag here. Let's expand it, okay. Click on this icon. Okay. Here we have different features. And For knowing more about these features, you can click on that and go to show help. Yeah. And in this file, we can see all the explanations. Okay, at first we have initial state object that we should determine that in end environment icon. Okay, so that describe the initial conditions inside the cylinder. Let's go to the model, main model, and then you can see these features. Okay, we determined that in the past. So we should determine pressure, temperature, composition, that we have air here. And the components of air. Okay. And about wall temperature, you should determine head temperature, piston temperature, and cylinder temperature. Determine unit here, for example Kelvin, and piston temperature is higher than head temperature, as you can see. Okay, here I have heat transfer object. Click on it. This is Voshny model that I choose. Okay, you can go to the help file, click on show help, and see the explanation about these heat transfer models. Yeah, here we have Voshny, GT, Flow, Voshny Classic, Voshny Sphere. As I said, we have explanation for each of them here. I have to determine head to bore area ratio, piston bore area ratio. Okay. Depends on engine type, over a square, or under a square. As you can see in this picture, we can determine bore stroke ratio. When bore is higher than stroke, we have high speed. Higher speed capability, larger valves possible, more peak power, and we can find that in many sport engines. So, a square engine, that's equal to 1. Bore equals to a stroke, equals a stroke. So we have balanced design here, and we have compromising between torque and speed. And under a square engine, the stroke is longer than bore. Yeah. And we have better fuel efficiency, lower RPM limit coming in diesel and economy engines. Yeah. Okay, again, let's go to combustion object, show help. Okay. Engine cylinder combustion, reference object that specifies the in-cylinder combustion model. Okay, to the advanced tab, we have different features again. Go to the show help. Okay. Scavenging object, for example, reference object that models scavenging. This feature models stratified gas composition in the cylinder so that the different mixture of gases can be exhausted through the valve than the average cylinder composition. About the scavenging object, the scavenging object is used to model the gas exchange process in engines where fresh, as you can see in this picture, fresh charge enters while exhaust gases are leaving the cylinder, mainly in two-stroke engines. It defines how effectively fresh air displaces burned gases, including mixing behavior and scavenging efficiency. And about evaporation object, it models fuel evaporation inside the intake port cylinder or manifold